Finally understand VFDs in 6 minutes. A simple guide for beginners. Imagine this. You're in a high-rise apartment. Early morning you turn on the shower. Perfect pressure. But then, your neighbors wake up. Peak demand hits, and your powerful shower becomes a frustrating trickle. What's worse? The old pump violently starts and stops. This noisy, damaging impact is called water hammer. The unstable experience? The broken equipment? That is the culprit. Why should we force a motor into a black or white choice between zero power and full blast? Imagine controlling it with the same finesse as the accelerator in your car, delivering just the right amount of force for the job. Well, you can. And the key that unlocks this incredible control is the true hero of our story today, the variable frequency drive. Hello everyone, I'm VFD Expert Girl. Join me and become a VFD expert. To control a motor, you have to control its power source. The power from our wall sockets is alternating current, or AC, with a fixed frequency, say 50 or 60 Hz. And because that frequency is fixed, the motor speed is also basically locked in. The mission of a variable frequency drive, or VFD, is to convert that fixed frequency power into power with a variable frequency. Think of it as a gearbox for electricity, and the entire process takes just 3 simple steps. First step, rectification. The VFD takes the wild, alternating current from the wall and tames it into stable direct current, or DC, the same kind of power you get from a battery. It takes the fluctuating AC wave and forces it to flow in only one direction. Then, a large capacitor, acting like a water reservoir, smooths out the electrical pulses, leaving you with a perfectly steady stream of DC power. So with our stable DC power ready, we now need a brain to call the shots. This brain is the microprocessor inside the VFD. We tell it exactly how fast we want the motor to spin, and it calculates the precise command thinking, hey, I need 30 Hz, or, give me 60 Hz now. Okay, so we have stable DC power, but we have to change it back to AC because that's what our motor needs to run. So how is it done? The secret is an incredibly fast electronic switch, known as an IGBT. The technique it uses is brilliant. Think of a light bulb. To make it seem half bright, you don't dim it. You just switch it on and OFF extremely fast. This trick is the VFD's core technology, PWM, or pulse width modulation. In a nutshell, you use the duration of the on time to simulate any voltage in between. Now that we understand the principle of PWM, building an AC wave is straightforward. We simply command the switches, use very short on pulses for the low parts of the wave, and longer on pulses for the high parts near the peak. By doing this, we literally piece together a perfect positive sine wave from the flat DC. And for the negative half, a second set of switches does the exact same thing, just in the reverse direction, completing the entire wave. But now for the most critical step. How do we control the motor's speed? In other words, how do we control the AC frequency? It all comes down to the speed at which we draw this wave. If we have the switches draw one complete wave very quickly, say in 1/50th of a second, the output frequency is 50 Hz, and the motor runs at its normal speed. But if we slow them down, having them take a longer time, say 1/20th of a second, to draw the wave, the output frequency is now 20 Hz, and the motor naturally turns much slower. And that is the ultimate secret to variable speed control. So, after going through all this trouble to manipulate the power supply, what's the big payoff? There are 2 core benefits. First, precise control. And second, and most importantly, incredible energy savings. Let's go back to the water pump from the beginning. If I only need half the water flow, the traditional method is to run the motor at full blast and then simply close a valve halfway. Half the energy is completely wasted. But a VFD can directly tell the motor to take it easy and slow down, outputting only the power that's actually needed, which leads to huge savings on electricity bills. It's because of these advantages that today the presence of VFDs is everywhere. From the elevators in high-rises and escalators in malls, to factory assembly lines, city water systems, and even in electric vehicles. Alright, let's do a quick recap. The principle of a VFD is actually very simple. First, it takes the fixed AC power from the grid and converts it into smooth DC power. Then, using its high-speed switches, it transforms that DC back into a new AC current where the frequency and voltage are fully controllable. This is how it achieves precise control over the motor's speed. So, in these past 6 minutes, I hope you've gained a whole new understanding of VFDs. If you found this video helpful, please don't forget to hit that like, subscribe, and share button. In the future, we'll dive even deeper into more fascinating topics about VFDs. Stick with me, and let's become VFD experts together. Thanks for watching, and I'll see you in the next video.